Am I live? So today we will be starting our introduction lecture on recursion. Okay, so let's write, like we will be doing a pretty simple intro lecture. Like it would be of okay. So there will be a building block of our lecture of recursion. Okay, so let's write the code of sorting a array. We know we can do it in log n, but we are not thinking about time complexity and all. We just want to learn recursion better. Okay, so we have an array. Let's array or vector, let's say vector, and let's say v. It has some elements. So 1 3 5 3, let's say 7 5 3 9 1 0. We want to sort it and print it. Okay, so sort function we will pass, and let's say we are passing the size also. Void sort vector v, passing it by reference to change it in code it, and what will be the sort function. Okay, our so we know we have two things. If we can take decisions, no, we can't take decision. So we think of smaller input. So we are trying to make it smaller, and we will be doing it by not recursion tree, not choice diagram. We will be doing it by our like base case, then uh, hypothesis, and then induction. So we'll think hypothesis, base case, then induction. So let's think of that. Do this smaller input. Yeah. So if sort function can solve like whole for n, then it should also solve for n minus 1. We leaving the last element, and then in induction process we will be uh, like if you eliminate the last element. Okay, so it would be 7 5 3 9 and 1. It should sort this up to, so 1 3 5 7 and 9 it should sort, and then the 0 would insert it in by after induction process insert function. So you do it insert function, which will be also doing by recursion. We can do it by iterative way. Let's do it. So the hypothesis is sort v n minus 1 base case. If let's say size is 1, then it is already sorted return, and if size is 0, then as a 0, then we have nothing to put. So n is 1 is obviously a thing that it is sorted. Then we have written the hypothesis, we have written the base case, okay, and now the induction. That is, we have to insert it nicely. Insert, or let us do it by iterative way. From 0 to, I think it should okay, 0 to n minus, size is decreased, n is n minus 1. Like for example, size is 5, so it should go up to 3. So, and if v of I is if v of I is less than or equal to, if v of I is to put it now, in induction process we have to just insert the element which we have eliminated, that is 0. So 0 should be put in its right position, 0 in the first position. We have to check whether v of I is less than, if it is less, continue, else we have to, so if it is greater, I think greater, it is greater than um, last element that we have already Hmm. Let us see. Let us do it by insert. Insert minimize it. There is no n. Why? You need n. One or after that you should, I think, you have eliminated the last element and just insert pushback. Say there is something wrong. There is something wrong. We have to just pop also, I think, because it is not doing it right. Pushback value or last element, let's say. Oh yeah, wait. I was not managing properly, I think. Making mistakes not problem. What is this? Oh shit. Let us. What's the problem is there? We're not doing it right fully. Let us do it again. Think of it again. Yeah, we have 7, 5, 3, 9, 1, 0. We just minimize it to 7, 5, 3, 9, 1 by popping the last element. Let's pop it. Yeah. So we have this. It would sort it because of hypothesis. We think about this and it will solving it. Then we have to just at last we have to insert that thing at its right position. So we've called the insert function. What does insert function will do? We have this thing 7, 5, 3, 9, 1 and 0 as our element to insert it. Okay, sorry, we have 1, 3, 5, 7, 9 and we have 0 as our element. So base case is that if this empty, then we can just put it. If we have last element which is smaller than this element, then we can just put it. If it is not, then we have move on to the hypothesis that we just pop the last element. Then we think that it would put it in its right position because we have if we have already done right, and then if the last position obviously it is maximum, so we have to put it again at its end. Now it makes sense. So if n is equal to 1, that is best case. If it is n is 1, then it is sorted. So return value is what last element, then v dot pop back. We just pop, yeah. So we have pop back, and then we just called it um taken it out and just called it in for v, and size is obviously n minus 1. Size was n, then n minus 1, doesn't matter. Then we just have uh this is the thing. Then we just have tried to make insert function which was v value, let's say n also. I don't know about this, but let's say n it has. So if n is 0 or last element is greater or smaller or equal to this, push back, return, element is the last element, then we just v dot pop back. The insert function, v value, you put it in its right position and then push this element in the back. Let's see, hope it will work. Why it is sorting it in the back order? Why? Should I remove this? Make like v dot size. checking stuffs. Wow, I knew it. The end doesn't make sense. If it does make sense, you should do. So this is the code, and it sorted it pretty nicely. What we have done is that we just have made a V. We call this sort V. Yeah, sort V. Then we have thought of the that is we thought of like smaller input because we are not thinking about the decisions to take. So we have thinking of smaller input. So we last element we just taken it out, and we thought that it would sort it perfectly is the hypothesis. Then we just have to insert it again in such a way that it is in a sorted manner. So we, and the base case is that if there is one element, then it is already sorted. So return is base case, pretty nice. And we have written the taken the value in -1, and then we have tried to just pop back. Last element is popped, and then we have, okay, we have sorted the v, that is reduced one. Then we insert the value and in the v. So we call the insert v. And what have you done? Hypothesis is that again to take the element, pop that element, it would be inserted perfectly. So the obviously last element we have taken, which is the maximum one, then we have to just put it again in its back. And the base case is that if there is nothing, you can put it, value is put in, yeah. And if or that the last element is smaller, the base case, which can you think of that, the base cases, like if the last element is uh, smaller, then we can just push last element smaller or equal. If it is equal also, then you can also push the element in the last. So that's all about. You have learned lots of things from this. So hope you like this video. Subscribe, like, share, and